I'm on page 87, and we are continuing with more of these problems. I did scaffold in a little variable box for you on these, so you don't have to draw these. And let me take a look here. I have a note with a question mark for this one, so I wonder what I'm talking about. Okay, let's get into this. On this page, I want us to round, if necessary, to the hundredths place. And remember, hundredths is 2 places. Aerial photography. A drone is flying 200 meters above the ground. So here's our drone. Its altitude is 200 meters. And here's the ground. If the angle between the drone's line of sight and the ground so right there is 20 degrees, how far is the drone from the photographer on the ground? I know now why I have a question mark. This is another one of those where it doesn't really specify which direction they want us to look at. Are we talking about the line of sight distance or the horizontal distance? So I need to make it clear which one I want us to find. And I want us to find the one along the, let's do along the line of sight. I think that makes more sense. So in other words, if the observer is looking up at that drone, what's the yellow line going to be? So let's make that clear. Originally, I did it with the pink line, but I think this makes more sense. So let's be clear about which one we want. We want this one, not the ground distance. Okay, so I'm looking for hypotenuse. That's line of sight. I know opposite because everything hinges on theta, and theta is 20. So we want H and O, that's going to be so. So the sine of 20 is going to be opposite over hypotenuse, which I'll make that be an H. And then we need to solve for H. Be careful with this one. That will cancel. So H is going to be 200 divided by the sine of 20. And I'm betting that it's going to be an approximation. But let's see. Let me get my calculator out here. So 200 divided by 20 sine equals about 584.76, and this is meters. So with that specification, I'm going to use sine. Originally, I had used ground, but I like sine better. Okay, cliffside view. A person standing 50 meters from the base of a cliff measures the angle of elevation to the top of the cliff to be 30 degrees. How high is the cliff? So here's line of sight. And that's hypotenuse, but let me get this one while I've got blue. Hypotenuse, and then the one adjoining theta is that one. So we know adjacent is 50 meters. We want to know opposite. Hypotenuse is not important this time. 30 degrees. So I want O and A. And that's going to be TOA. So the tangent of 30 is equal to the opposite, that's the cliff, over the adjacent, and we need to do the math. So the cliff is 50 times the tangent of 30, and that is about 28.87 meters tall. And that's about right for a cliff. Always ask yourself, does it make sense? Climbing a ladder. A ladder makes a 70-degree angle with the ground. If the ladder is 12 meters long, how high up the wall does the ladder reach? So we have adjacent, hypotenuse, and opposite. We want to know opposite. We do know hypotenuse, and we do know theta. So H and O are related by the sine ratio. So the sine of 70 equals opposite, which is the wall, over hypotenuse, which is 12. And we multiply 12 by both sides to cancel it. So W is going to be 12 times the sine of 70. So the wall is about 11.28 meters. And again, that is reasonable for a wall. A climber is ascending a mountain path. So the climber is going up this path on the side of a mountain that makes an angle of 35 degrees with the ground. If the climber has traveled 200 meters along the path, how high above the base is the climber? So we want his altitude, the height. Opposite, adjacent, hypotenuse. We know hypotenuse. We want to know opposite, and we know theta. H and O are related by the sine ratio. So sine of 35 equals opposite, which is the height, over hypotenuse. And then algebra takes over. So the height will be 200 times the sine of 35. Height is about 114.72 meters.